with the problems in the book, and again, these are on page 116, okay? We're going to be looking at some applications of our derivative rules that we have learned up to this point as it applies to position, velocity, and acceleration, okay? And so the beginning of problem number 97, right above it, it says in exercises 97 and 98, use the position function. So you guys need to write this down as part of your notes. Position function, S of t equals negative 16 t squared plus v sub 0 times t plus s sub 0. All right, so this is the position function for free falling objects. Okay, now this should look somewhat familiar to my folks who have taken physics. Yeah. So we need to talk about like what this has to do with.
That's a negative 1, right?
That's a negative 16. Okay, sorry. That's a negative 16. All right, so what this is based off of is, and these are just kind of some side notes you can take, this is based on acceleration due to gravity, since it's free falling. Okay, and technically gravity is negative 32 feet per second. Later we're going to look at it in meters per second. All right, and so you know what, I'm going to change it just a smidge because I want you to see how the G gets plugged in. All right, so, and maybe this will, technically it's negative 1/2 G t squared plus v sub 0 t plus s sub 0. All right, so I changed the negative 16 to negative 1/2 G because I wanted you to know where the negative 16 comes from, okay? So when we're talking about something, and that would be feet per second squared because it's acceleration. When we're talking about distances in feet, okay, and time in seconds, gravity, the acceleration from gravity is negative 32 feet per second squared, okay? So if I plug that in, okay, for G up here, that's how I actually get the negative 16, okay? If gravity is in meters per second, we're going to plug in something else. Now, I do want to tell you what the other things stand for, okay? And my physics folks may know this, all right? V sub 0, the starting velocity. So initial velocity. And S sub 0, well, since it's my position function and the variable used here is S of t, that's going to be your initial position. Okay, so where are you starting from before the object falls? Okay, so we're looking at free falling objects. Okay? All right, so now we're going to look at problem number 97 from the book. And it says a silver dollar is dropped from the top of a building that is 1,362 feet tall. And the first thing I want to do is actually come up with a, since it says determine the position and velocity functions for the coin, I want to write a function, okay? All right, so I am going to have to slide it down a little bit so we can actually work the problem. I wonder if it will let me do this. Aha. Maybe. Okay. Here we go. That's what I need to see all at the same time. Okay. So, again, you might want to label your paper. We're doing problem number 97. All right. And the first thing I want to do is actually come up with a position function. Okay. Now, if I had not given you the fact that it's negative 16 in front, you would have had to read the problem to see that it's in feet, and then use the negative 32. Okay? So, the 32. So, the negative 1/2 times 32 is my negative 16. So, I'm writing a function. All right? The function has to leave t's in it. All right? Now, if all I'm doing is dropping it, what is the initial velocity? 0. Okay, so then that whole middle term goes away, right? But then what's my initial position? 1,362. So there is my position function. Position function for this problem. Okay, so this is all part A. Then it says also determine the velocity function. Well, what's the connection between position and velocity? Okay, so velocity is the derivative of position. So now you know how to take the derivative of that function without a calculator or anything. That's a power rule, right? What's the derivative? Negative 32t. Okay? So all of that is part A. Okay? Part B says determine the average velocity. All right, so I want you to think about it. That's the average rate of change. Okay? So it's kind of like something we've done with the tangent line. It's a difference quotient. It is literally the slope of a secant line. Okay? So when I relate it to velocity, okay, it's the position function evaluated at the end of an interval minus the position function. So instead of f of b minus f of a, it's s of b minus s of a, all over b minus a. Okay? Think about the mean value theorem. The average rate is equal to the instantaneous rate, so the average is that difference quotient. Okay, so this specific problem says determine the average velocity on the interval from 1 to 2. All right? So for this specific question, average velocity is going to equal s of 2 minus s of 1 all over 2 minus 1. All right, now, how am I going to find s of 2 and s of 1? I'm going to plug it into my s of t function. All right, so take a minute and do that math. You can use a calculator, I don't care. do we have an answer yet? What'd y'all get? Okay, and then I need some units. All right, now, let's talk about how you get feet per second. Okay, well, you know it's a rate of change because it's velocity, but also because the top of your difference quotient is s of something. It's a position. Our position is in feet. The bottom are times in seconds. So again, that's how I would get my units. These are feet, these are seconds, so my answer is feet per second. Are we okay with that? Okay, now the next question says find the instantaneous velocities when t equals 1 and t equals 2. So part C is specifically asking me to find v of 1 and v of 2. All right. Just v of 1 and v of 2. You should not need a calculator for this, okay? Because we actually knew how to find v of t, right? Didn't we find v of t right here? So if I want v of 1, then I'm literally going to plug 1 into it for t. What do I get? Negative 32. What would the units on that be? Feet per second. Because it's a rate of change in the distance over time. All right, and then v of 2 would be negative 64 feet per second. Okay, so that was the third question. All right, let's see. D says find the time required for each coin to reach the, for the coin to reach the ground. Oh, okay. So do you know some of this because of physics, or like you were just already ahead of the game here? You just understood the question. Okay, so the whole idea of finding, find the time for the coin to reach the ground, we're finding the time when its position is the ground, but that means you're a zero distance, right? And so for D, we want to find when the position, S of t, is equal to 0, okay? So then hopefully you can find your S of t that you wrote earlier. And I want you to take a second and solve for t. And yes, you may use a calculator. If you get decimals, please round to 3 decimal places. So we hit the ground when the position equals 0. All right, do we have a time yet?
Yeah.
Okay, 9.226. Now, keep in mind that technically when you solve equations, like when you take the square root, you're supposed to get plus and minus, but this does represent time. Time can be negative, so we only need the positive one here, and these are seconds. And so that means it takes, we're saying it takes 9.226 seconds for the coin to hit the ground. Are we okay with that? All right. Then the last part of the question, I gotta scroll back up, says find the velocity of the coin at impact.
9.226 and 0, and then don't you do the one?
No, because I actually want the velocity at the time when the coin hits the ground. Do I know when the coin hits the ground?
Yes.
Yes. So I want the velocity at that time. Do I have the velocity function?
Yes.
Good. Then I need to plug it in. Then I need to plug in 9.226. It is that simple. All right, my folks at home, feel free to type these answers in the chat box. What decimals are you getting? It shouldn't take you too terribly long to figure out what negative 32 times 9.226 is. Thank you, Fuad. Now, either I miswrote something or I didn't round. Did any of you leave the full answer for time in your calculator and hit times negative 32? Because I will tell you, like on the AP exam, keep in mind, and I could have mistyped something. Keep in mind on the AP exam, you may write down a rounded answer, but if you have to use it to get another answer, you cannot use the rounded answer. You have to go back to your calculator and use the entire thing.
Yeah, it's 2.242.
Yeah, I got a 4.242.
Yes, that's the full.
Okay, yeah. So if you go back and you use the full 9.2 to whatever, and then you multiply that by negative 32, you would actually get negative 295.242. Okay, what are the units on that? Feet per second.
You have to leave it as negative.
Yeah, velocity is speed with direction.
Yeah, I didn't know if you wanted us to leave it as.
Now, if I asked you what the
Downwards.
speed was, all right, if I asked you for what the speed was, all right, so this is just like an extension, all right, so if I said what's the speed at 9.226 seconds, okay, that would be the absolute value of velocity at 9.226 seconds. Because velocity is technically speed with direction. So to take the direction off, I would really take the absolute value. That thing is moving pretty quick, right?
Mm-hmm.
All right, now, let me go back up. One question I didn't ask you in the beginning was find a function. Let me label this one real quick. Find a function for acceleration. What if I asked you to find a function for acceleration? All right, why is it negative 32? Because it's the derivative of velocity, which then means it is the second derivative of position. So that is some notation that you need to be familiar with. Acceleration is the first derivative of velocity or the second derivative of position. So it's got two prime dashes instead of one.
So is that like the gravity?
Yes. All right. And so then if you go back and look about what we talked about, why g was negative 32, it's because g is acceleration due to gravity. And so the acceleration of all free fall problems is negative 32. Okay? So make sure you add that into your notes. So if I asked you for what is the acceleration at time 2, what would it be? It'd still be negative 32, right? Okay? Now, I want to throw, I don't know if I want to throw it in yet or not. I feel like it's going to come up at some point, and I don't know where to throw it in. Okay, so let's go back to part C and add some extra stuff. Okay, so I just said, what if I asked you for the acceleration at time 2? And you guys told me what? Negative 32, and that would be feet per second squared. Okay? Now, here's a completely different question. Is the object speeding up or slowing down at time t equals 2 seconds? Is the object speeding up or slowing down? So I didn't ask what the speed was, even though we could find it. What would be the speed at 2? What would be the speed at time 2? It would be positive 64, but that's not the question. I want to know, is it speeding up or is it slowing down? Okay? And here's how you tell. And like, find somewhere to write this, circle it, box it, whatever. All right? An object, well, I'm not even going to do that formal. I'm just going to say speeding up when, right? We know that it'll be speeding up when velocity, so I'm just saying v of t, and acceleration have the same sign. Whoop, skipped a word. Have the same sign. And I'm running out of room here. So under that, go down here, we would be slowing down when velocity and acceleration have different signs. All right, so get that written down. That's a very important concept. Make sure that you put that together. Okay, keep that somewhere. All right, so now let's go back up. And I want to know, is the object speeding up or slowing down at time 2? Speeding up. Because they have the same sign. It doesn't matter that they're both negative.
You really only have to check the velocity because the acceleration doesn't change.
Right, well, yeah, but I mean, if it was some other function that wasn't based on gravity, you could still tell if something's speeding up or slowing down by comparing those two values. Okay, and that's a very common AP question. Is something speeding up or slowing down? Because they want to make sure that you understand you have to check velocity at that place and acceleration at that place and compare their signs. Okay? All right, some of y'all need to shake it out. Stand up and stretch for a minute. Yeah, so we're writing down what we know. We have an initial position of 220 feet. We have an initial velocity of, good. And because it's in feet, we also know that we're working with acceleration or gravity, right? Our gravity is going to be negative 32 feet per second squared, okay? And we need that because of the position function, right? We have enough information to write a position function. It's it's 1/2 times g. Did I write negative 1/2 on the other slide? Oh, g's already negative.
So the 1/2 isn't.
So in the very beginning, get rid of, like, the 1/2 is not negative, the g is negative. Sorry. Shame on me. Okay. So then when I take 1/2 of it, I still get that negative 16t squared. Right? Except this time I have an initial velocity to go with the middle term. And I have an initial position. All right, so what does that do to help me with my question?
Now you have a function.
Now you have a function.
You can find the velocity.
You can find the velocity function by doing what?
Bring the derivative of it.
Taking the derivative of it. Okay, what do we get?
Negative 32t minus 22.
Good. And so now I can actually answer the question, what is the velocity after 3 seconds? So find v of 3. All right, we're good with that? What'd you get? Okay, and you always need to label your units when we're dealing with application problems. Okay, next question says, what is its velocity after falling 108 feet?
So you subtract position 220 minus 180 to see where it is at when it's falling.
How will this go? There. All right, so what are you saying?
The position is 220 minus 108. It's saying it's falling 108 feet. So you need to find the position that it's at right now.
Okay, so, right, so if it fell 108 feet, all right,
Mm-hmm.
then position is now 220 minus 108, right? 112, okay? So then the question is really saying when, I gotta find a time, when position equals 112.
Are you finding the time? I thought this is what is its velocity after falling?
Right, but it says after falling 108 feet. So I need to know when that happens.
Okay.
Yeah, so I've got to find a time of when that happens so that I can then plug it in. All right, so I can then plug it into velocity. All right, so take your position function, set it equal to 112. All right, solve for t, and I will tell you, you will need your calculator to figure that out.
The original function you said?
Yeah, the position function, because I want to know when does s of t equal 112. All right, and think about what algebra that's going to require.
Ugh.
You got to make it equal to 0. Technically, I can take out a -2. But that's it on the factoring. Okay? Well, how do you solve a quadratic equation that doesn't factor? Yeah, so you can use the quadratic formula, or, why did I say calculator? What can you do on the calculator to find where that quadratic function equals 0? All right, what about y? What do you do with it after you plug it into y1?
Do the graph, do the zero.
Yeah, you get the zeros off of the graph. And you only have to worry about positive times, right? So I would absolutely graph that thing and find the zeros, all right? And make sure you're not using the trace feature of your calculator. You're actually calculating a 0, all right? So take a minute and do that. I do want to make sure that you know what you're doing on your calculator. You don't actually need the -2 in there. You can leave it if you want. We should still get the same zeros even though our graph won't look the same. So if you graph it, all right, you should see that only one side of the parabola crosses a positive x value. I told you, I did not put in the -2.
Neither did I. And I can't even see mine. Mine didn't show up. And
Hit zoom 6. Does that fix it?
Unless it's just loading, no.
No, you've hit enter too many times. See how it's doing that thing right there? And then there you go. It's got it.
It's still not
All right, stop hitting enter.
there.
Okay. It's -50. Okay, sorry about that. Okay, so how do you find a 0 on your calculator? What do y'all press? Second trace, number 2. Now, the reason why you don't see the blinker on the screen is because it always starts at the y-intercept. And it says it's all the way down at -54. All right, so it's at 0 down at -54, so I need to go to the right because I only care about the positive one. All right, and you know, you got to pick something to the left, pass it, something to the right, and then whatever the calculator will let you get as close as possible. Okay, you got to hit enter 3 times. How was that? I did not get exactly 2. Did you guys get exactly 2?
Yeah, my calculator said 2 0.
Huh. Okay. Well, all right. Well, that means that thing could factor, but that's okay. All right, so if my 0 is at 2, then I come back over here, and this happens at time 2, right? This happens at time 2, but that wasn't the question. The question was, and I gotta scroll all the way up, what is the velocity at that time? So then I need to find v of 2 to answer that question, okay? Well, did we ever find v of t? Yes, we did. So we're gonna plug in 2, -32 times 2 minus 22. And I have decimals on my paper, so I don't know how I got that. What'd y'all get? And that would be feet per second. Okay? All right, any questions right now? Benson, that's fine. I can't even see you anymore. I don't know where you went. Okay. All right, so real quick, I just want to show you So I'm not going to work through the next couple of problems, but I just want to show you what's different about them. So on 99 and 100, it gives you a different position function, okay? It has the coefficient negative 4.9, and that's because if you read through the problem, it talks about meters per second, okay? So technically, the position function is still, and I did it again, is still based off of the same 1/2 gt squared plus initial velocity times t plus initial position, but g is negative 9.8 when you're working in meters. Okay, so I know those of you that took physics, you hopefully recognize the 9.8.
Well, technically, it's negative 9.8
Oh. Well, you don't ever have to go that far in this, I've never even heard that, and
Hey, Mr. Flickenberg,
he got real technical on that.
he was solving up.
Okay, so then that's why they want you to use, well, the textbook has you using negative 4.9 t squared, because when you take half of 9.8, you get the 4.9. And so you can answer similar questions, okay, just in different units. So I feel like that would just be redundant of what we've already done. All right, so we still have some time. Let's take a quick